Hello, my name is Chris Shank.
And I'm Orion Reed, and we're here to present our paper, Live Programming in Hostile Territory.
Make sure to check out our research at folkjs.org and our paper at folkjs.org/live-2025. Our paper begins with the observation that live programming tends to gravitate inwards towards the creation of fully circumscribed universes. This creates a dynamic where the success of these environments is measured by domination, achieving adoption by displacing rather than integrating with the existing tools and practices. Whether this is intentional or not, this is usually justified as a means to explore and experiment with new forms of liveness.
Traditional programming, which makes use of text files and text editors, leverages ubiquitous plain text infrastructures that resist single system dominance. Plain text, or human readable formats, are really misnomers, as plain text is a vast web of infrastructures including ASCII, UTF-8, text editors, text field or text area UI widgets, terminals, keyboards, string types, object-to-string rendering functions, human-readable format libraries, tokenizers, parsers, escape sequences and input sanitization, base64 encoding, line ending and whitespace conventions, and the fallback flavor of the copy-paste clipboard. So, human readable really just means ubiquitous infrastructure. This infrastructure is not to be taken for granted, and we should not assume that it will emerge naturally for live programming environments.
Rather than accept this inward trajectory of live programming environments, or to wait for new ubiquitous infrastructure to naturally emerge, we advocate for this community to extend its research from the creation of new environments to the augmentation of existing ones. This is what it means to do live programming in a hostile territory, to do it outside the comfy walls of your live programming environment where you have full dominion. In this vein, we propose three adversarial strategies to situate live programming in existing context of use. We believe the key to enabling outward facing integration and moving beyond success by domination strategies is free addressability, which seeks to maximally advertise the structure of the application via a transparent addressing scheme without requiring permission or coordination from the original creators. Our strategies exploit the fact that user interfaces expose more addressable surfaces than the underlying program. Adversarial annotation challenges the assumption that live programming requires purpose-built environments. It shows how some types of live programming can be achieved through lightweight annotation on existing addressable surfaces. For example, while web-based systems will often break if the structure of their DOM is modified, they often tolerate addition of new attributes that encode interactive functionality. Furthermore, annotation encourages the decomposition of functionality typically trapped within these environments. Here we demonstrate how adversarial annotation can be used to turn WobbleWeb, an HTML-first graphics editor encoding environment, into a real-time collaborative environment via the addition of a single HTML attribute. In the DevTools console, we load the attribute via CDN into two separate instances of Wobble. We then annotate the same element with the folksync attribute and the ID of the shared CRDT document. Wobble is now a collaborative live programming environment. The attribute achieves similar functionality to systems like WebStraits by syncing DOM subtrees via CRDT, but without requiring migration to a dedicated platform. Notably, Wobble makes it easy to embed another live coding environment called Hydra into it, which also becomes collaboratively editable. This shows how our adversarial approaches of annotation and embedding can be combined together. While adversarial annotation augments existing systems in place, adversarial embedding makes whole systems composable to the outside world. It acknowledges the default conventions, security policies, and architectural assumptions that treat these systems as discrete, non-composable units. In some cases, cooperation from an environment's author is needed. In other cases, when systems provide no embedding interface, protocols can be used adversarially to force integration around existing boundaries. In this demo, we show a sand physics simulation interacting with DOM elements, including those that live across iframe boundaries. It uses a post message protocol that is injected adversarial into the iframe via web extension that ultimately enables the outside world to observe bounding box changes. Um, this establishes real time bidirectional communication between systems that typically exist in isolation. In this second demo, we show what a spreadsheet looks like when it's designed to be freely addressable through a surface like the DOM. Not only can this spreadsheet be easily embedded into any web page, this approach enables all kinds of permissionless augmentation. Here's how it works. Each cell in the spreadsheet is a custom HTML element. It is addressable via its row and column attributes. It contains an expression to evaluate and a value that is the output of that expression. It also includes a list of dependencies extracted from this expression that are themselves other HTML elements. Propagation of values happens through DOM events dispatched from the cell, meaning anyone, including other cells, can observe granular data dependency changes from the inside and outside of the spreadsheet. The default styles and layout of each cell can be overridden, just like all HTML elements. All of this together, we can create new visualizations of the spreadsheet based on the underlying dependency graph.
When systems provide no addressable surfaces, adversarial extension creates addressability by repurposing whatever infrastructure remains available. Unlike annotation, which works with systems designed to tolerate additions, or embedding, which requires systems that allow runtime code injection, extension operates on closed systems which do not tolerate addition to their internal state or modification to their execution environment. Accessibility APIs represent one addressable infrastructure ripe for reappropriation. Operating systems expose accessibility trees to support assistive technologies, creating a parallel addressable representation for every running application. While this interface provides only a limited view of application state focused on user-facing elements rather than internal program logic, it offers near universal coverage across every running application. Our prototype demonstrates how this infrastructure can be repurposed for external augmentation. A WebSocket server connects a web overlay to accessibility and windowing APIs, making it possible to query, subscribe to, and modify the interface state of any running application. This creates an addressable surface where none existed before. This prototype shows the Ivory messaging application augmented with two external interfaces, an editable outline view of its accessibility tree, and a regex-based find and replace interface for text editing. This regex functionality, absent from Ivory itself, demonstrates the kind of read-write querying possible across boundaries we usually consider closed. Proprietary applications with no APIs, closed-source code, or deliberate restrictions on extensibility. Since applications cannot opt out of accessibility infrastructure without breaking assistive technology compliance, this approach works even with systems designed to resist external intervention. And the same augmentations can work universally across any application. When users experience live programming capabilities situated in place rather than sequestered in dedicated environments, we hope they begin to see such integration as normal rather than exceptional. We believe pluralistic practices that subvert intended boundaries create pressure like water finding cracks, persistent forces that gradually reshape systems towards openness. We believe this community needs to confront the question of change. How do isolated programming tools evolve into integrated, composable ecologies without falling into success by domination strategies? Our approach rests on the belief that fragile bridges and adversarial interventions create social pressures that drive systemic change. These prototypes point towards a future where external composition is a design assumption rather than an afterthought. While our prototypes remain fragile and limited, they point to a future where live programming capabilities become as ubiquitous as plaintext itself. The question is not whether any single system will achieve domination, but whether we can work within our inherited circumstances. In this view, live programming research becomes work of transformation rather than escape.